Welcome to Raw Machines, a journey exploring the most remarkable processes around the world. Today we travel to Bergisch's land, where steel files are shaped entirely by the rhythm of hammers, chisels, and the sensitivity of human fingertips. No modern assembly lines, just raw steel, home-based workshops, and skills passed down through generations. A slow, demanding craft, yet precise to a remarkable degree. Let's begin. With its hilly terrain cut by valleys and small streams, Bergisch's land provided a favorable setting for family-based crafts to endure across generations. In this context, around 1800, the craft of file grinding and cutting, known in German as Feilenhauerei, began to take shape in Old Polhausen. This trade formed a stable branch of small-scale ironworking, operating through a clearly defined spatial division of labor. Steel blanks were forged in Remscheid, ground in workshops along the Eschbach stream, and then brought back to Polhausen, where the teeth were cut and the files finished entirely by hand. In 1948, a home-based workshop on the valley slope was converted into a machine-driven file-cutting shop, marking a clear step toward mechanization in a long-established craft. Even so, the modern cutting room still relied on south-facing windows for daylight, an enduring work habit. The cutting machines, based on British inventions from around 1900, enabled expanded production in Remscheid. While machines produced uniform grooves, many stages still depended on manual skill, especially for specialized files. Workshop culture persisted in the machine room, visible on walls covered with photographs and postcards. The figures show a decline, from 45 workshops in 1900 to 5 by 1939, not disappearance but contraction in order to endure. Workspaces were typically small annexes attached to the home. Ties with Remscheid were maintained through weekly deliveries and payments, establishing a steady rhythm of work. File blanks were transported in long baskets known as Levermenken, each holding 6 dozen pieces. When fully loaded, the baskets weighed over 80 pounds, and the worker used a shoulder staff to ease the burden. Labor therefore extended beyond the workshop and accompanied every step of transport. On a later filming occasion, the last hand file cutters were invited back into the workshop. After nearly 10 years of disuse, the space and equipment remained largely unchanged, allowing the working process to be reenacted almost in full. Inside the room, a small shelf at the narrow end held 5 different types of files. The blanks brought in were 5-inch triangular saw files, a form still used today for sharpening saw teeth. The workers' hammers ranged from 250 grams to 7 pounds, with short curved handles for precise control. Along the window stood oak anvil posts, set about 70 centimeters into the ground. Parallel to the rear wall lay a sandstone grinding wheel known as a warte, taken from a workshop in the Eschbach Valley after it had worn down to a diameter of 1.20 meters. The worker sat astride a 3-legged stool, positioned close to the cutting anvil. At the top of the wooden anvil post sat the amelt, an iron block fixed along the grain of the wood and serving as the anvil face. Before any cutting could begin, each blank had to be carefully prepared. For saw files, the edges of the forge blanks were trued with a coarse file, as forging rarely produced perfect straightness. The tang was secured in a hippen pole, a specialized spring clamp, consisting of 2 steel arms and a movable wooden support block.
Hij moet die vat uit dat in hebt. Oh man, daar heeft u nog mee. Kom maar op, pa. Dat je nu.
The blank was placed at an angle on the amelt, stabilized with a thin cardboard pad. After lubrication with an oil-soaked leather pad, blanks were paired and held firmly by a foot-operated tension strap. Alongside the hammer, the cutting chisel was the central tool, its hardened edge used to strike sharp notches into the steel surface. When breaking edges or introducing an incline, the lightest hammer was used, applying just enough force to raise narrow ridges with single, fine blows, even before the blank had been annealed. This preparatory work often involved women and children. Within a file-making household, each member carried out a specific task, forming a continuous and closely linked chain of labor. Before cutting the teeth, the blanks had to be annealed to reduce brittleness and ensure stable cutting. This process was usually carried out on the household stove, where domestic life and craft production overlapped with little separation. Annealing required slow heating until the steel reached an even red heat. A rack holding 1.5 dozen small files was placed directly on the stove above the grate, and the process lasted about 30 minutes. Once the proper temperature was reached, the blanks were not quenched but allowed to cool slowly, typically on the stove ledge in the cutting room. The well beside the house and the entire workshop compound date back to the 18th century. In 1876, a worn grinding stone was reused as the well's base and cover. The well supplied water for household use, the workshop, and the livestock. Alongside their main trade, file cutters maintained small-scale farming, largely carried out by women. Simple wooden sheds housed tools and, in the workshop annex, 1 or 2 cows. The stable stood directly behind the workroom wall, a quiet contrast between hammered steel on one side and everyday warmth on the other. In the workshop, the grinding machine is set in motion to resharpen a worn chisel. To drive the heavy grinding stone by the foot pedal near the floor, 2 men are required. The round sandstone wheel, known as a worte, is moistened with water to sharpen the edge. The chisel blade is ground smooth on both faces within a narrow band to form a sharp bevel. Chisels for coarse cuts are double-sided, with equal angles on both faces. Single-sided chisels, used for finer grooves, are asymmetrical, with one face ground more steeply than the other. An experienced craftsman sharpens the blade to last for about 5 dozen files. To remove the oxide scale, a curved wooden block was clamped in a vise. The worker used a grinding file to strip away the scale. These files had to be prepared in large numbers and had their teeth recut regularly to maintain cutting efficiency. Once the scale was removed, the metal surface was exposed and leveled. The curved block provided support points for files of different sizes, allowing uniform cuts to be made later. Even after cutting machines were introduced, many saw files still depended on manual skill. The tapered bodies of triangular saw files could not be cut accurately by machine until the 1930s. When the blanks were ready, the A-melt was set in place. At the center of the anvil lay a grooved lead pad. Using a triangular steel bar, the worker deepened the groove and tested the cleaned blank to ensure even support along its length. Any foreign material was scraped away with the flattened tang of a file. Before cutting the teeth, the blank had to sit correctly, a fundamental rule of the trade. Once the blank was properly seated, the finishing of the cutting chisel began. A chisel sharpened on a coarse stone was not yet ready for use. The first stage produced the main bevel. A secondary bevel then formed the true cutting edge. This was done on a fine-grained, flat Belgischer Brocken stone. moistened with water. The resulting slurry allowed the two bevels to meet in a sharp central edge. The remaining microscopic burr was removed on an oil stone with a guiding groove along its narrow edge. Sharpness was tested with the fingertip. Within the trade, touch was the most reliable measure. The craftsmen worked in a row along the window, with only a narrow passage between stools and grinding stones leading to the end wall shelf. Traditionally, workers specialized in specific file types. Triangular saw files alone existed in 22 variants, ranging from 4 to 12 inches. The 3-pound cutting hammer and the small chisel head were regularly rubbed against the wooden anvil post to improve grip. During early apprenticeship, the hammer often slipped, but years of repetition turned the movement into a controlled, almost automatic skill. After completing one face, the craftsman rubbed charcoal onto the surface to prevent lead from the anvil pad from sticking in the grooves. The next face was cleaned and lightly oiled with a felt roller. On the anvil pad, the file blank was held in place by the hunkin and a tensioned strap. In earlier times, resin was used to keep the chisel firmly between the fingers. Each hammer blow had to be delivered with steady force. The upper arm stayed close to the body, while only the forearm moved. Cutting began at the front, with the chisel slightly inclined toward the body, running across the surface at an angle of about 60 degrees, careful at first, then settling into a regular rhythm. For triangular saw files, a single-edged chisel was used to create narrow, sharp grooves. Each cut pushed a ridge of steel forward. The following cuts were placed directly against this ridge, making fingertip sensitivity decisive. The hammer blow had to bite fully into the steel without bouncing or slipping. A 5-inch saw file had about 20 cuts per centimeter, with a daily output of roughly 3 dozen pieces. In 1913, 20 dozen earned a weekly wage of $7. By 1934, the same amount brought 30 marks. A quick check with the thumbnail was enough to tell whether the cuts were even. The second cutting anvil was used for larger files with a round cross-section. For 10-inch round files, the coarse bastard Hebe cut was applied in parallel longitudinal bands. A lead pad on the anvil was shaped to match the file's profile, ensuring even support. produce deep cuts on narrow bands, a cutting hammer of about 3 pounds was sufficient. Its curved handle was held firmly in the palm, allowing precise guidance of each blow. Round files for curved surfaces were the most difficult to control. The craftsman used the little finger as a support point while guiding the chisel along the cutting band to prevent deviation. When reaching the tang, the next band was rotated upward and lubricated. Because the file extended beyond the anvil, the tension strap needed only to loop over both ends for securing. In the first cutting pass, 8 bands were completed, leaving 8 alternating bands untouched and later reset at the vise. During scale removal and surface truing, great care was required to avoid damaging the newly formed teeth. A flat file was moved lightly and parallel between adjacent bands. In the subsequent pass, the remaining bands were cut in sequence. If the chisel was inclined to the left in the first pass, it was inclined in the opposite direction in the next. The adjacent bands formed a zigzag pattern, improving the file's cutting action. Even after many years away from the trade, the craftsman's hands retained their calm and precision. The wooden anvil posts were set with the grain facing upward and cushioned with moss at the base. This created a slight elasticity, improving the penetration of each hammer blow and subtly shaping the cutting process. The last file cutters in Polhausen came from families rooted in the craft. The only craftsman still active during filming had mechanized early, yet his manual skill remained intact, because the craft lived on in his hands. From the seemingly minor details of the anvil and wooden post, the craftsman's skill moves on to a more demanding task, producing square files with a double crosscut. The 12-inch square file was a common tool in machine shops. Simple versions, requiring only straight cuts, were mechanized early. Here, however, the focus is on a complex cross-cut file with 2 overlapping layers of teeth. Working 10 hours a day required a seated position carefully matched to the body. Proper use of hammer and chisel depended largely on posture. The first layer, known as the undercut, was made with the chisel angled from upper left to lower right. For the overcut, the craftsman shifted position. On the surface already cut and smoothed, the chisel was guided in the opposite direction, creating a crossed pattern that divided the first cut into narrow ridges known as shrum. This crosscut produced countless small teeth, allowing the file to bite sharply into metal without clogging. Because of its complexity, no more than 6 files could be completed in a day. The square file was cut on a zinc-lined anvil to protect the finished teeth, hard metal resting on softer metal to preserve its edge. In file cutting workshops, production was governed by the weekly delivery cycle. To ensure sufficient output by Friday, daily production was counted every evening. Charcoal dust had to be brushed from the finished files before packing. When women and children assisted, the work sometimes turned into a lively communal moment, filled with conversation and song. When the files left the workshop, they were not yet ready for use. At the factory, the previously annealed steel had to be hardened again through heat and rapid quenching. This was followed by straightening the files, which often warped during hardening. To protect the teeth during transport, the files were wrapped in newspaper in bundles of half a dozen, a method that also simplified counting and payment. In total, 64 bundles, 384 files, were placed into the delivery basket. Because newly cut files were highly sensitive, they were covered with cloth to protect them from moisture. The file cutter's work attire was a blue apron, which was always removed when stepping outside. When the craftsmen returned to Polhausen, they carried home not only their wages, but also the work for the coming week. The cycle repeated itself, steady and unbroken, like the rhythm of the hammer. The S. Klein File Cutting Workshop was not merely a place where tools were made, but a space where history, skill, and working life converged. Within the network of village industries in the Bergisches Land, file cutting emerged as a small yet essential link, connecting textiles, ironworking, and mechanical crafts in a decentralized system rooted in family labor and inherited experience. Inside the workshop, steel was shaped not by force, but by knowledge and rhythm. From annealing beside the household stove, to sharpening chisels on the wart-grinding stone, to the steady hammer blows on the amelt, every step required patience, discipline, and a refined sense of touch. The contrast between raw material and finished tool reveals the core value of manual labor, precision rather than speed. Industrialization did not erase craftsmanship, it clarified its worth. Machines increased output, but they could not replace the adaptability and experience accumulated in human hands. As a result, home workshops continued alongside factories, preserving the most refined aspects of the craft. Above all, the S. Klein workshop shows that labor was inseparable from everyday life. The stove served both cooking and annealing, families shared in preparation, and production followed the rhythm of daily living. When the workshop became a museum, its anvils and hammers carried more than form. They preserved a work ethic, deliberate yet exacting, modest yet enduring, a quiet legacy of lasting value. Thank you for staying with us until the end of this story. If you enjoy documentaries like this, please like, share, and subscribe so you won't miss future stories. Raw Machines. Thanks you, and we look forward to seeing you again.